Morning. Today's class, chemical properties of alkenes. Here, alkenes are double bonded unsaturated hydrocarbons undergo electrophilic addition reactions. Here, first one, addition with halogens, that is bromine. It undergo trans addition reaction. Alkenes on addition with chlorine or bromine in the presence of halogens carries like carbon tetrachloride or ferric bromide form vicinal dihalides. Example, ethylene molecule CH2 double bond CH2 plus bromine in the presence of carbon tetrachloride. It gives 1,2-dibromoethane. It is trans addition takes place. It is a vicinal dihalide. Similarly, ethylene upon treatment with chlorine in the presence of carbon tetrachloride, it gives 1,2-dichloroethane is called ethylene chloride is a vicinal dihalide. Similarly, butene, 2-butene treatment with chlorine in the presence of carbon tetrachloride, it gives 2,3-dichlorobutane, which is a vicinal dihalide. Here in the mechanism, when bromine molecules comes nearer to alkene, the negative pi electrons cloud of the alkene brings about the polarization in the bromine molecule. It get one bromine get partial positive charge and another bromine atom get partial negative charge. First, the positive charged partial bromine atom attacking at the double bonded carbon. It gives the pi complex, that is C double bond C Br, which is a pi complex compound. This complex being less stable decomposes to give carbonium ion, which form a cyclic bromonium ion is a intermediate product. Here the cyclic bromonium ion by attacking here by gaining the electron compared with carbon, the electronegativity of bromine is more. The carbon bromine bonded electrons are polarized towards the bromine atom, then it gives carbonium ion. This carbonium ion attacking with the bromide ion, Br minus ion, it gives 1,2-dibromo, trans 1,2-dibromo ethane. During the bromination, a trans addition takes place due to the formation of cyclic bromonium ion as a intermediate product. Next one, second one is addition with halogen acids. Here alkenes react with hydrogen halides, forming alkyl halides. Again, alkenes react with hydrogen halides, forming alkyl halides. Example, ethylene CH2 double bond CH2 plus HCl undergo electrophilic addition to give ethyl chloride. Similarly, in this addition of hydrogen halide to a symmetrical alkene gives only one product. One is ethyl bromide radical, ethyl bromide. Similarly, 2-butene upon treatment with HBr, it gives 2-bromobutane. Here, addition of hydrogen halide to unsymmetric alkenes give two possible products. This reaction can be explained by Markovnikov rule. Once again, here generally in addition of hydrogen halide to a symmetrical alkene gives only one product, but addition of hydrogen halide to the unsymmetric alkene give two possible products. This reaction can be explained by Markovnikov rule, which is the important rule. Here, first Markovnikov rule is stated as unsymmetric alkenes. Unsymmetric alkenes upon treatment with halogen acid or hydrogen halide, the negative addendum can attack least number of hydrogen containing carbon besides the double bonded carbon is called Markovnikov rule. Once again, here Markovnikov rule is stated as unsymmetric alkene upon treatment with hydrogen halide or halogen acid. The negative addendum can attack least number of hydrogen containing carbon besides the double bond is called Markovnikov rule. Here the mechanism is explained. Electrophilic addition of HBr to the propene. Propene is a asymmetric alkene. Here when HBr is added to the propene, two types of products are obtained. One is 1-bromo-propane is a minor product. 2-bromopropane is obtained as a major product. It is explained by Markovnikov rule. Means here asymmetric alkene addition with halogen acid or hydrogen bromide. The negative addendum of bromide ion can attack least number of hydrogen containing carbon besides the double bond is called Markovnikov rule. Therefore, according to Markovnikov rule, propene upon treatment with HBr, it gives 2-bromopropane as a major product. In the mechanism, first step, HBr molecule undergo forming ions, or it undergo heterolytic cleavage to give H plus ion is an electrophile, Br minus ion is nucleophile. Then attacking the H plus ion to the carbanion. Hence, the electrophile adds to the carbon forming secondary carbonium ion. Here, this carbon double bonded electrons are polarized towards the carbon. This carbon gets negative charge. The middle carbon gets positive charge. The H plus ion attacking at the negative end of the carbon atom, it gives secondary carbonium ion is obtained as a major product. Secondary carbonium ion attached by the nucleophile bromide ion, then it forms 2-bromopropane as a major product. This product is called Markovnikov product. This product is called Markovnikov product. Next, hydration. Hydration means addition of water. Here, when alkenes are passed into the 20% sulfuric acid, 20% sulfuric acid means then rest of the 80% is added with water, the dilute sulfuric acid. When alkenes are passed into the 20% sulfuric acid, they combine with water to form alcohol. That is CH2 double bond CH2 plus H2O. In the presence of acid media, it gives ethyl alcohol. Again, in the mechanism, it is a three-step mechanism. One is in the first step, a proton from an acid attacks the carbon-carbon bond, double bond to form an intermediate carbonium ion. That is CH2 double bond CH2 plus H plus ion. This proton attacking at the negative end of the carbon, it gives intermediate carbonium ion is obtained as a product. Then attack by water. Here in the second step, the water molecule attacks the electron deficient carbonium ion to form protonated alcohol. That is, due to the presence of lone pair electron on the oxygen of water, it attacked the carbocation to form, that is the protonated alcohol. In the third step, loss of proton. In the final step, the protonated alcohol loses proton to form an alcohol. That is, it gives ethyl alcohol. This protonated alcohol lose proton by the heterolytic cleavage to form ethyl alcohol as a major product. Next, addition of hypohalous acid. Here, when alkenes are treated with hypohalous acid or hypochlorous acid or chlorohydrin is formed. Here, in the hypochlorous acid, OH get negative charge, Cl plus Cl get positive charge. Here CH2 double bond CH2 plus H4Cl, it gives chlorohydrin. 2-chloro, 1-propanol is obtained. Similarly, propene, which is a asymmetric alkene. Upon treatment with H4Cl, here the negative addendum means OH minus attacking at the least hydrogen containing carbon, that is 2-hydroxy 1-chloropropane is obtained as major product or Marconi-Ka product. Here in this halonium ion is produced by cleavage of HOX bond. This add to double bond forming cyclic halonium ion, that is RCH double bond CH2 HOCl. This attacking at the chlorine end, it gives the cyclic chloronium ion is obtained as a intermediate product. Then the cyclic chloronium ion attacking by the OH minus ion at the trans end, opposite end, it gives trans 2-hydroxy 1-chloroalkane is obtained as a major product, or it is also called Marconi-Ka product. Next, addition of sulfuric acid. Here alkenes react with sulfuric acid at room temperature to give alkyl hydrogen sulfate, that is CH2 double bond CH2 plus sulfuric acid, it gives CH3 CH2 HSO4, that is ethyl hydrogen sulfate. This ethyl hydrogen sulfate undergo hydrolysis to give ethyl alcohol plus sulfuric acid byproduct. In the mechanism, sulfuric acid ionized to give H plus plus HSO4 minus. The proton attacking at the negative end of carbon in the unsaturated alkene, it gives carbonium ion is obtained as intermediate product, that is CH2 double bond CH2 plus H plus to CH3 CH2 plus. Then this CH3 CH2 plus plus bisulfate ion, it gives ethyl hydrogen sulfate. This ethyl hydrogen sulfate undergo hydrolysis to give ethyl alcohol plus sulfuric acid is obtained as byproduct. Here, next, anti-Marconi-Ka rule or peroxide effect or crash rule by the addition of HBr to the unsaturated asymmetric unsaturated hydrocarbon, that is in the next class.